Hey, good morning, afternoon, and evening. My name is Vincent, and this is the title of my research proposal, Utilizing Capsule Network with Attention Mechanism for Radar and Video-Based Human Activity Recognition. This research is under the supervision of PM Dr. Wall, and co-supervisor is Dr. Noor Hidayah. And without further ado, let us begin. This is the table of content for this presentation. So let's go to number one, problem statement. So what are the problem statement that we pinpoint before proceeding with our research? These are the four that outline. So before this, for human activity recognition models, they're all based on CNN models, which are computationally heavy. So if you want to do human activity recognition, like what is the person doing, moving, jumping, or whatnot, traditionally it has all been CNN based or RCNN, deep CNN, all that, all the deep CNN, all that, all those have one thing in common, which are they are very computationally heavy. So we want to come up with another solution that is not as computationally heavy and also be able to produce the same, if not better, accuracy compared to the traditional CNN based on. Second is poor generalization and complex spatial hierarchies. It's because this. Why do we say this? Is because all the HAR models are based on CNN models, which are all using scalar data. So what the capsule network do is they use vector data. So they have magnitude and angular and angle. So the magnitude is the probability. So probability is what CNN has. We also have another data, which is the angle. The angular data represents the pose or the direction where the person is facing. So if we combine these two, we will have better generalization. And the third problem is high inference time, which is unsuitable for real-time and embedded system. As this also goes back to computational heavy CNN-based model, is they are very powerful, they are very accurate, but the problem is you need a very fast system to train, to run, and to test all the models, which in real-time scenario, right now we do not have the technology or the means, the fiscal means or monetary means to implement this in real-time embedded systems, because those things are still too heavy to be carried onto embedded applications, and we want to try to solve this. And the fourth one is there's in the market there is a need for lightweight yet accurate deep learning framework. So this is what we want to bring to the market, because in the market they are already very well established HAR models, human activity recognition models, but they are all limited by the computational heavy CNN models. So this is what we want to try to solve. So what are the scope and the research questions that we have? Okay, so the scope that we want to focus on is we want to focus on two domains, radar and video-based HAR, and we want to develop CapsNet, capsule network plus attention mechanism. These two in combination should be able to fix the problem that we mentioned previously. And so deployment on feasibility on edge devices on those embedded devices, and we want to target that particular genre. So what are the research questions that we have? Can CapStack with attention improve HAR accuracy and generalization? Can 2D spectral domain transformation enhance the representation of the data, the output? And is it feasible for real-time and embedded implementation? This is what we want to try to answer in our research. So we have the four objectives for our research. Number one is investigate feature extraction using radar and video. We want to develop a 2D spectral transformation for all these for the radar and video data. We want to design optimize CapsNet with attention mechanism. That is the title of our research. And number four is we want to benchmark the performance with state-of-the-art models. The state-of-the-art models are all the CNN-based models. And we want to compare how our model perform compared to the state-of-the-art benchmarks. Okay, this is the literature review that I've gone through so far. So I've gone through four different kinds: radar-based, video-based, and capsule network-based. There's all from within 5 years from now, 2022, 2023. I can see HAR-based one. We can get 96%, 97% accuracy. We want to try to get as close as possible, if not better than all these. Okay. What is the expected outcome? So we have these four: novel capsule network architecture with attention for HAR. This is what we, at the very least, want to be able to achieve. We want a framework that functions first, and then we can work on improving the classification and accuracy. That is the second step, and also the computation, and also the computational concept. Okay. And then the third one is real-time development on edge or embedded system devices. This is further down the line. And the last one is better generalization in complex and dynamic environments. This is the milestone and timeline for the project. I've started my PhD on late April. So this is what I'm currently doing, trying to do more literature review, learn what other people have done, and so we can learn from their mistakes and then their completion. Also, data collection, model development, training, evaluation, and finally the final report. Conclusion. This research proposed a novel HAR model combining two different backbones of CapsNet with attention mechanism. And the solution that we seek to achieve is to improve accuracy and efficiency for development in healthcare, surveillance, and even smart environments. This is the reference that I can fit in a slide. There's more, but I didn't fit everything in here. So the last one, Q&A. This is the question that is being posed. Main contribution. So the main contribution of this research is we want to produce a lightweight, accurate HAR framework using CapsNet with attention and a novel 2D spectral representation for activity signal. This is the output of, because we're using vector, right? So we have 2D spectral representation instead of just traditional one dimension or scalar. So this is vector. So impact to industry and community, enhance real-time monitoring in healthcare. So if we can get a better framework that can do more, we can improve all these. These are all dominated by CNN models right now. So we want to improve on that. And the last one is promote efficient AI development on edge devices. That is all. Thank you so much.